Now see, in the previous class, we came to know how to calculate E naught cell. From a representation or an equation, you can easily calculate it. We got a formula that is E naught cell will be equal to E naught cathode minus E naught anode. And just take care of it that whatever is the value of E naught cathode, it should be SRP, that is a standard reduction potential, and this should also be a standard reduction potential. Since I am using not, that's why I am writing a standard. If there is no not, like E cell will be equal to E cathode minus E anode. That means we need to write the value of reduction potential and reduction potential at anode. So please, do you have any doubt? Then ask me.
No,
Sneha
sir.
and Hamza. Okay. So in the previous class, we have also completed a topic that is feasibility or spontaneity. We can easily tell that, we can easily prove that whether a cell is feasible or spontaneous, whether a cell is feasible or not feasible. A spontaneity of cell or reaction. Here we got a formula that is delta G naught will be equal to minus NF E naught cell. So what you need to do is just see the representation of or the equation. You can easily calculate the value of N. N is basically number of electron lost or gained. F is constant, and I told you the value of F is Faraday's constant, 96,400 coulomb, and also E naught cell has a formula, E naught cathode or E naught right minus E naught left. We can use this and calculate the value of E naught cell and then put the value here. And we know that whenever delta G is less than 0, that means the process or the reaction is a spontaneous. And if delta G greater than 0, that means non-spontaneous. And if the process, if delta G equals to 0, that means the process is at equilibrium. So please keep this in mind. You have already studied this in class 11. So I'm going to give you a question on this formula. Please write it. So the question is, find a standard gives free energy. Find a standard gives free energy and predict the feasibility of cell. Predict the feasibility of cell. And it is also given that Zn slash Zn plus 2 double slash Cu plus 2 slash Cu. And here it is given that E naught Zn plus 2 slash Zn is has the value minus 0.76 volt. And it is also given that E naught Cu plus 2 slash Cu is given as plus 0.34 volt. So how we are going to say whether a cell is feasible or not? A spontaneous, that means the cell is feasible. If the value of delta G naught is in negative or less than 0, that means the cell is feasible. And if the value of delta G greater than 0, that means positive, that means the cell is not feasible. So please do this question and let me know if you have any doubt. I'm waiting. Sneha, can you do this? Okay, thank you. Hamza,
Yes, sir.
can you do this? Or you need explanation?
No, sir, I can do it.
Okay.
Sir, E naught cell is 1.1.
E naught cell is 1.1.
Yes.
Now calculate the value of delta G naught and tell me whether the cell is working or not, feasible or not feasible.
Sir, F value will be same, right?
Yeah, F is
0.6.
constant. This is called basically Faraday's constant. In the previous class, I have written it all. After calculating E naught cell, you can easily tell me whether it is feasible or not.
Sir, what will be N?
N is the number of electrons. You are going to write an equation for this, and from this representation, you can easily write an equation. And from the equation, you can easily tell me the number of electron lost or gained. Both will be equal. Number of electron will be lost, so the electrons which is lost will be gained by another element. So N is basically number of electrons. Sneha, any answer? First of all, see, I'm going to explain it. It shouldn't take this much time. You can see, find a standard gives free energy. We have a formula delta G naught is equal to minus NF E naught cell. And you know that F, we know the value of F, and we can easily find the value of N. From this, we can easily write an equation, oxidation half reaction. On the left hand side, you can see Zn is going into Zn plus 2. That means it lost 2 electron. So it is oxidation half reaction, and this is a reduction half reaction. That means Cu plus 2 is converting into Cu. That means it gains 2 electrons. So after adding this oxidation half reaction and reduction half reaction, you will get an equation Zn plus Cu plus 2 will give Zn plus 2 and plus Cu. Now these electrons will be cancelled. Now you can see the number of electron transferred is equal to n is equal to 2. N is equal to 2. F has already, I told you, it is a constant and it has a value 96,500 coulomb. Now we need to calculate E naught cell. E naught cell has a value that is E naught cathode minus E naught anode. Cathode, right side is cathode, that means Cu plus 2 and Cu. So go for it. And before writing the value, check whether the E naught value is of oxidation potential or reduction potential. So Cu plus 2 going into 0, that means it is a standard reduction potential. So just write as it is 0.34 minus. At anode, you know that this is anode, zinc left hand side, and this is also a standard reduction potential is given. So you just you need to put the value as same as that, and you will get an answer 0.76, that is equal to 1.1 volt. You got all the answers. Now see, delta G, after finding E naught cell, you can easily predict. After finding delta E naught cell, you can easily predict whether it is feasible or not, because you know that in formula it is there is negative. N is always positive because it is number of electrons. F is positive because F is basically constant, which is positive 96,500 coulomb. So the delta G naught, spontaneity and non-spontaneity, feasibility or not non-feasibility, depends on E naught cell. If E naught cell is positive, here I got E naught cell positive, positive into negative, delta G naught will be negative. So if E naught cell is positive, that means it is feasible. If it will be negative, E naught cell will be negative, that means negative into negative in the formula multiply and it will be positive. So wherever there will be question whether the cell is feasible or not, you just need to calculate the value of E naught cell and see whether it is positive or negative. If E naught cell is positive, that means cell is feasible. And if E naught cell is negative, that means cell is not feasible. But here I have given you the question in which it has been asked that what is the value of delta Gibbs free energy. So we just need to put the value minus, then number of electrons 2, and then Faraday's constant 96,500. And what is the value of E naught cell? Just multiply it and you will get your answer. Sneha, Hamza. Please write it and let me know.
Yes, sir. One zero six one four eight, sir.
Very good. Sneha, are you done with this? Okay, let me know when you are done with this. Sneha, are you done with this? Okay. Now I'm going to give you another question. Please do it on your own. Predict the feasibility under a standard condition. Under a standard it is given that the reaction is directly given. Ni plus 2H plus will give Ni plus 2 plus H2. And it is also given that Ni E naught, E naught Ni plus 2 slash Ni is minus 0.25 and E naught H plus slash H2, half H2 is given as equals to 0 volt. Please do this first. You just need to calculate. You just need to tell me whether the cell is feasible or not. And for calculating feasibility, you just need to check the sign of delta G naught. Okay. I'm going to write here one more step and also find
Sir,
or
can you come?
calculate. Wait a minute. Also find or calculate delta G naught. Yes. What you just said, Hamza?
Sir, can you do the answer?
Answer is so easy. You just need to what we need to calculate. We need to predict whether the cell is feasible or not. So you need to apply the formula delta G naught is equal to minus NF E naught cell, and we need to check the sign of delta G naught. And can you tell me the value of N or number of electron transferred from this reaction? Yes or no?
No, sir.
Hamza? No. Can't you find the oxidation state from class 11? There is a chapter, redox reaction, in which you have learned how to calculate oxidation state.
Sir, 2.
Yes, it is true. You just need to check whether the this is a balanced equation. Yes or no? This is a balanced equation, and Ni is in elemental form, so its oxidation state is 0. Just check for it, and 0 to it is going into plus 2. That means it just lose 2 electrons. So the number of electron will be 2. F is already given, that is 96,500 coulomb. Now you need to calculate E naught cell. E naught cell has a value formula E naught cathode minus E naught anode. Yes, and you know that at cathode there will be reduction, and at anode there will be oxidation. So you can see in which is oxidized and reduced, nickel and hydrogen. Can you tell me? Can you tell me whether nickel is oxidized or reduced, or 2H plus H plus is oxidized or reduced? Sneha, Hamza,
Yes, sir.
which one is oxidized and reduced? Can you tell me, or you are not able to understand it? Let me know.
So Na is being
Oxidized,
oxidized.
that means this is at anode and this is at cathode.
Yes, sir.
So cathode, that means this is 0, is the cathode value of this. 0 minus anode, you can see nickel, and this is a reduction potential. So I'm going to put the value minus 0.25, and you will get an answer 0.25 volt positive E naught cell. Yes or no? So you are going to put the value 0.25, which is positive. So you can see in the formula there is negative and all are positive. So negative into positive, that will be negative. So it is feasible. And after multiplying, you will get the value of delta G naught. Yes, got it. Sneha, please do reply. Write it. Very good. Hamza, are you done with this?
Yes.
Okay, thank you. Now see, the next topic is very important, which is Nernst equation. Nernst equation. So I'm going to write the Nernst equation, which is very easy. We have already completed the basic terms of electrochemistry, E naught cell and all. Now see, Nernst equation has a formula, that is E cell is equal to E naught cell minus 2.303 RT upon NF log of product concentration of product upon react. You know what is this? This is basically just like Kc you have studied in class 11. Like if you have an equation AA plus BB, that gives us CC plus DD. So if you are going to calculate the value of Kc, and all are by default in aqueous solution, all are in aqueous solution, all are in aqueous solution. So you just need to keep it in mind, whatever the concentration of C, whatever is the concentration of C, this will be like this, product upon reactant. product upon reactant. And one more thing which is very important is that whatever is its coefficient, that is called stoichiometric coefficient in chemistry, will be the power of its product and reactant. Sorry, wait a minute. The stoichiometric coefficient of C is C. A stoichiometric coefficient of D is small d. A stoichiometric coefficient of A is A, and a stoichiometric coefficient of B is B. So this is how we are going to write the value of product and reactant. Always keep keep it in mind that whenever we will talk about pure liquid and pure solid, if the physical state is pure liquid and pure solid, pure liquid and pure solid, that means liquid and solid, you are not, the value equals to 1. That means we are not going to write it because its value will be 1. Just suppose that if we are, we have an equation CaCO3 in solid that is converting into CaO, that is solid, plus CO2, that is gas. So if you are going to write the value of product upon reactant, you can see only the product is in gaseous state, so it will be like this. And if you are going to write this, you don't need to write this because it is in solid state, and neither you are going to write this because it is also in solid state. So whether it is in solid state and liquid state, we don't need to write it. Okay, now see, I'm going to write another formula of this, another form of this, which is very important. Before that, E is basically electrode potential. Electrode potential at any concentration. At any concentration and temperature. E naught is a standard electrode potential. A standard electrode potential, and I already told, I already taught you about the standard condition, that is concentration is 1 molarity, temperature is 298 Kelvin or 25 degrees centigrade, and pressure is basically 1 atm or 1 bar. A standard electrode potential. R is gas constant. R is gas constant. T is temperature. T is temperature. F is Faraday's constant. F is Faraday's constant. That is a value that is 96,500 Coulomb. In some questions, it will be given the value of F will be like it will be taken as 96,000 according to the question. So if the value of F will be given in the question, please use that question. Please use that value. And N is basically number of electron gained or lost. Number of electrons gained or lost. R is basically concentration of reactant. Concentration of reactant. And P is basically concentration of product. Concentration of product. So please write it. Then I'm going to write another form of this after putting the value of R, temperature at some standard condition, value of F. There will be another form of this. Please write all this. Please let me know when you are done with this. Very good. Hamza, are you done with this? Hamza? Okay. Now
Yes, sir.
see, after putting the value of all that we can put, E will be equal to E naught cell. And after putting the value of R, temperature, and F, we got 0.059 upon N log of product upon a reactant. And here, whenever it is in log, the base is 10 in the previous equation also. We just don't need to write it, but here I just wrote it. Please write this. Then we will do some questions, which is very easy. And from representation, you need to write an equation. You know how to write an equation. If I have given an equation representation like m plus and m, you know that this will be m plus n is converting into m, that is oxidation state 0. And how, and here the oxidation state is plus n. How it becomes 0? When it gains n electron. So this is our product, and since it is in solid, its value will be 1. Upon reactant, this value will be given. Wait a minute. This value will be given, this concentration. And if the representation is like this, you know, m is going into m plus n, that means 0 to m plus n, that means it lost electron. And this is now product, which in aqueous solution it will have some concentration that will be given. You need to put it here, and this is in solid state, so the value of its concentration of reactant will be. So please write this and let me know if you are done with this. Then we are going to do some questions. You need to apply this formula, not the previous. Hamza, are you done with this? Sneha? Sorry.
Yes, sir.
Thank you. Very good. Now see, I'm going to give you a question. Please try it. Find the reduction potential. Just don't jump on a reduction potential. You need to calculate according to your Nernst equation. E cell is equal to E naught cell minus 0.059 upon N into log product upon reactant. After calculating E cell, you can easily calculate a reduction potential. So see, find the reduction potential and oxidation potential of, oh, wait a minute, of Fe plus 2, which has 0.01 m, that is molarity, slash Fe, which is in solid state at 25 degrees centigrade. It is also given that E naught Fe plus 2 slash Fe has a value that is minus 0.454. This is given. E naught cell is given. Let me know if you are unable to understand, then I am going to explain. Are you getting anything, Hamza? Should I explain it now? Sneha. Tell me, please. Hamza and Sneha. Sneha and Hamza, any answer?
No,
Sneha, Hamza. Now see, I'm going to explain. We need to calculate. Okay. We need to calculate reduction potential and oxidation potential of Fe plus 2 0. I told you to use Nernst equation. So E cell will be equal to E naught cell minus 0.059 upon N log to the base 10 log product concentration of product upon reactant to the base 10. Now see, E naught cell is given as minus 0.45. This we can write directly 0.45. And from this, you can write an equation that will be equal to, that Fe plus 2 is converting into Fe. And Fe is solid. And how it will be converted? It gains some electrons. And in aqueous solution, whenever in aqueous solution, ionic state, it will be in aqueous solution, which has a concentration that is 10 raised to the power minus 2 m. Yes or no? This is product, this is reactant. Now see, minus 0.05, 0.45, then 0.059 upon number of electrons gained or lost. You can see two electron gain, then log to the base 10. And what is the product? It is in solid state, so we just need to put one here, and reactant that is in aqueous state, which has a concentration 10 raised to the power minus 2. Now you just need to solve it. See, minus 0.45 minus 0.059 upon 2 log to the base 10, and you know that when it moves to numerator, negative will be positive, and it will be 10 raised to the power 2. Now we are going to use a formula of log. If there is log to the base b and a raised to the power n will come to here, and it will be n log a to the base b. So what you need to do is just keep 2 here, and you will get your answer. Minus 0.45 minus 0.059 divided by 2 into 2 log 10 to the base 10. And whenever these are same number, then the value is 1. Then the value is 1. And you know that this 2 and 2 will be cancelled. And here you can see minus 0.45 minus 0.059. Can you tell me the answer of this? 0.45. I'm just going to calculate it. 0.45 minus 0.45, 0.45, and then 0.059. So the answer will be minus 0.509 volt. Now this is electrode potential, and you know that electrode potential will be equal to reduction potential. So the value of reduction potential will also be equal to minus 0.509 volt. And you know that oxidation potential is minus of reduction potential. So minus minus multiplied, and it will be positive. So 0. Plus 0.59 volt. Please write. Oxidation potential will be positive. This will be negative. Let me know when you are done with this. Thank you, Sneha. You are also done, Hamza. Now the next question is, calculate or find reduction potential, same question, and oxidation potential of chromium Cr plus 3, which has a concentration 0.01 m at 25 degrees centigrade. It is also given that E naught Cr plus 3 slash Cr is given as minus 0.75 volt. Please do calculate. I'm waiting. Can you do this? Hamza, Sneha,
Yes, sir.
are you able to solve it or not? Sneha, please
Yes,
do
sir.
reply. Okay, I'm waiting. Please let me know. If you have any doubt or if you don't get it, let me know. I'll explain it again. Okay. Very easy question. You know basics of log, which is very important, and in most of the cases, this will be used. The power will come here and it will be n log a to the base b. And in this type of question, there will be log 10 to the base 10, which has a value 1. And this power n will be in multiplication. So please let me know. I'm waiting.
Sir, can you do it?
Yes, yes, why not? Now see, this is also as easy as the previous one. Same question. You just need to understand the concept. Find reduction potential, oxidation potential. We will apply E cell. E cell has a value formula. E cell will be equal to E cell minus 0.059 upon N log of product upon reactant to the base 10. Yes or no? Tell me. Now, from this, you can easily write an equation that is Cr will be converting into Cr plus 3. This is in aqueous state and this is in solid state. And its concentration is given as 10 raised to the power minus 2m. Are you getting my point, Hamza? And
Yes, sir.
E naught cell is also given as this. This is E naught cell given. So you just need to put the value and you will get your answer. E naught cell has a value minus 0.75 minus 0.059 upon 0.059 upon N. Now see, you can see that Cr is converting into Cr plus 3. That means 3 electrons it will lose. So 0 to plus 3. That means the value of N will be 3. And again, log to the base 10. And here the product is basically Cr plus 3. So the Cr plus 3 has a concentration that is 10 raised to the power minus 2. Upon reactant, you can see it is in solid state. So we are going to take value 1. Now you just need to calculate this minus 0.75 and I'm going to round it off 0.059. I'm going to write it 0.06 divided by 3. And you know that this is power. This is wait, let me extend one more step. 10 raised to the power minus 2 to the base 10. Now again, it will be easily cancelled by 0.02 times. So the value will be left with minus 0.75 minus 0.02. And you know that when it is in power, it will come here. So multiplied into minus 2. And here we will have log 10 to the base 10, which has a value 1. Yes or no? Hamza? Hamza, are you getting it? Now
Yes, sir.
again 0.75 minus, if you are going to multiply it minus into minus, it will be plus, and 2 to the 4, 0 point like this, and you can solve it. And you know that electrode potential will be reduction potential and oxidation potential will be negative of reduction potential. So just solve it and you will get your answer like 0.75 minus 0.04, it will be minus 0.71 volt. So reduction potential is minus 0.71 volt and oxidation potential will be positive. Let me know when you are done with this. Very good. Everyone done with this? Hamza?
Yes, sir.
Very good. Now I'm going to give you another question, which is very important. Find EMF of cell. See, I had given you the first two questions in which only there will be reduction or oxidation. Okay, but in this question, I'm going to give you full cell reaction. Find the EMF of cell. Find the EMF of cell. Cr in solid slash converting into Cr plus 3, and in which it has a concentration 0.1 m slash Fe plus 2. Wait a minute. You will do as I say. Fe plus 2, which has a concentration 0.01 m slash Fe. It is also given that E naught Cr plus 3 slash Cr will be equal to minus 0.75 volt, and it is also given that E naught Fe plus 2 slash Fe is minus 0.45 volt. We need to calculate EMF. So do as I say. First, you are going to write an equation from this representation. So please do as I say. Write an equation from this representation. I have already taught you how to write an equation from a representation. And let me know when you are done with this, with the equation or reaction. And if you still have any problem in writing the reaction with the help of representation, please let me know. What is the reaction you got, Sneha? Please write the reaction in chat box. Hamza, can you write the reaction from this representation? Hamza,
Yes, sir.
Sneha, please write the reaction in chat box. Hamza, please do reply at least. Are you doing it or not?
Yes, sir.
So
I'm
the
trying.
reaction is very bad. Uh, Sneha, you can see from representation, Cr is going from Cr to Cr plus 3. Cr to Cr plus 3, not Cr plus 3 to Cr. Are you getting my point? You have written the reaction as 2Cr plus 3 plus 3Fe will give 3Fe plus 2 plus 2Cr. Now you can see from the representation, Cr is going from chromium is going from Cr to Cr plus 3, not Cr plus 3 to Cr. Are you getting my point? Please correct it. Yes, it is Cr plus 3, sir. But you can see now, you have written the equation 2Cr plus 3 Fe. Okay, typing error. So, so you are going to write the reaction as Cr is going into Cr plus 3 and Fe plus 2 is going and Fe plus 2 is going into Fe. To balance this equation, you need to multiply it by 2 and 2, and you need to multiply it by 3 and 3. This is the perfect equation. Yes or no, Sneha? This is the right equation from the representation. Okay, Hamza?
Yes, sir.
Hamza, are you there? Now
Yes, sir.
see, this is the equation we got, and total number of electrons n will be equal to 6. N will be equal to 6 because here it is 0 and it is going in plus 3, and there are two atoms. So one for a one atom it will be 3, but we are going to take two atoms. That's why it will be number of electrons will be 6. Now, can you calculate E naught cell from this E naught cell? The value of E naught cell is equal to E naught cathode minus E naught anode. Okay, please do this. Tell me the value of E naught cell. 'Hamza, what is the value of E naught cell?
0.75 minus 0.45.
0.75 minus 0.45. E naught cell, which one is cathode? Iron is on cathode or chromium?
It's 0.3.
Iron is on cathode.
Not cell is
You
0.3.
can see This is very easy question, and if you are not going to solve it easily, E not cell, this is very bad. On the right, I told you already from representation, this is cathode, this is anode. So on the cathode, you can see this is our iron. So we are going to put the value 0.45 minus at anode, you can check 0.75. So it will be minus 0.45 and plus 0.75. It will be 0.30. Yes or no, Hamza? Now going to apply the formula. E cell will be equal to E naught cell, minus 0.059 upon n log of product upon reactant to the base 10. Okay. Now again, what is the value of E naught cell? 0.3 minus 0.059. What is the value of number of electrons? That is 6. Log to the base 10. Now go before writing product and reactant, going to see what is it, what is in product and reactant. Since it is in metallic form, so its value will be 1. And Cr plus 3 has a value 10 raised to the power minus 1. And you can see on the reactant side, this is in solid, that's why it will have a value 1. We are not going to write it, but this has a value 10 raised to the power minus 2. Again, if there is some stoichiometric coefficient, so we are going to take power also. Okay, so you can see on the product side, what it is. On the product side, we get Cr plus 3, concentration raised to the power 2, because it has a stoichiometric coefficient 2. And on the left hand side, reactant side, Fe plus 2 raised to the power 3, because its stoichiometric coefficient is 3. In the previous question, there was no stoichiometric coefficient. That's why we didn't have anything in power. Now we are going to solve it. 0.3 minus 0.059 upon 6 log to the base 10, and this has a value 10 raised to the power minus 1 raised to the power 2 upon this has a value 10 raised to the power minus 2 as a power 3. Please solve it and let me know the answer. If you are still unable to solve it, let me know. Sneha, did you get the value? Hamza?
Yes, sir.
What is the value? You can see 0.3 minus 0.059 upon 6 log to the base 10, and this will be 10 raised to the power minus 2, and this will be 10 raised to the power minus 6. After going in numerator, it will be 0.3 minus 0.059 upon 6 and log to the base 10. and it will be 10 raised to the power plus 4. Again, this will come here, and 0.30 minus 0.059 upon 6 into 4 log 10 to the base 10. This will have a value 1. And now, can you solve it or not? You both are not doing anything at all. 0.059 upon 6 into 4. Just solve it and you will get your answer. And please ask me if you have any doubt in this, because I'm going to give you another question that will be almost same. So if you have any doubt in this, please. Let me know when you are done with this. Hamza, are you done with this?
I'm doing so.
Okay, you're doing. Please let me know when you are done with this.
Sir, answer is 0.261.
Yes. Find EMF of cell at 25 degrees centigrade. Zn slash Zn plus 2 0.1 m double slash Sn plus 2 0.01 m slash S. It is also given that E0 Zn plus 2 slash Zn is equal to minus 0.76 volt, and E0 Sn plus 2 slash Sn will be equal to minus 0.14 volt. Sneha, can you solve it? Hamza?